Okay, so in general, I would say the exams were not. I don't know, in general, they weren't horrible. Some of the questions that people missed, I wasn't happy. Like way too many people missed the conversion question, which I don't know. It was actually an easy question, and when we solve it, you'll see. I mean, you didn't have to do a lot of heavy math. But in any case, I think some people who I expected to do better, it was clear that they didn't do as well as they should have done, maybe because of time. We're scrambling at the end where it was going pretty strong, and then all of a sudden you get like minus a whole bunch of points in like the last two or three because they basically didn't fill them in. So those are pretty obvious. Folks who seem to have time and kind of just blah, 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 whatever. So 4 people got an A. We had no Bs, a couple of Cs, some Ds, a couple of people just under that. So I would say if you're, in this range, 50 or higher on the test, I think you are probably in a reasonable enough area. I mean, things in this range could be more of a time factor, or things just haven't quite clicked yet, but you earned a good number of points on a good number of questions. So I wouldn't be overly concerned. You start, these 4 folks, I would be more concerned. Decide among yourselves whether or not this was more of a test-taking skill set issue versus a not prepared issue versus, whatever. So, but hey, we didn't have any zeros. So, like I said, I've had zeros before from like people who like don't answer like a large percentage of the questions, right? But I've never had a student had 3 pages of work they turned in with this. I mean, it was full effort. This was full effort. I tried. I mean, I'll usually look at a question, and if like I have no idea where you're going with it, but it looks like you sort of kind of might think you know what you're talking about, I could throw a 3 on it or something. Like something. How could he give me like 3 or 4 pages of material? I even wrote a note at the top of it. It's like, this is terrible. so, no, I look forward to that. I'm not even sure if I'm not sure if I know the person. It's one of 2 people in class, so it's it might be somebody who doesn't show up very often. I typically don't even learn people's names until they're like juniors or seniors. I just don't care. I mean, like kind of like lesser things, right? I barely know most of your names, but I've had you for years. Tina, right? I did just pass them out, right? I know everybody. All right, so average was 65, but that was kind of thrown off. We did have, I think, 2 100s in the class, so those folks did well. But really, anybody who's in this category is obviously doing very well. That was just, points for some stupid twist on a question they missed or something like that. Generally, every now and then you'll have somebody who basically writes the answer key and then answers one question completely stupidly. Like you don't even understand why. Like where that came from. Something like that. So, I don't know. I always find that funny, kind of like those injuries we were talking about. All right, so let's go through the exam. I'm glad I have an extra one to and this one's actually one of the answer key ones, so there's only one 100 floating out here. Who is it? All right, so let's look at this guy. How do I want to? It might be easiest to solve it in here. Oh, you want to hear another interesting, I guess, potentially creepy fact? Most of you know I don't listen to music, right? There's a song I can't get out of my head. And it's the new Taylor Swift song. I'm too old to be embarrassed at this point. Because I really like listening to just the soundtrack of Transformers. I just like that kind of the techno beat stuff, so I don't want too much voice interjected in there. Like I like like Jurassic Park theme, like so the instrumental, what they call it, epic instrumentals or something like that. I don't know, there's just something about the beat to that song I kind of like. There's like this one part in the chorus that when she starts singing that, but I hate it. So I actually fast forward through that part.
Wait, which song
Ready for it. I mean, is it good or is this like really bad that I like it?
Is it like just like the intro that you just like keep on skipping? Like you just play the intro, or I'm trying to think of where the beat part.
No, like the whole, no, just throughout the whole song. Yeah, but there's this one part, the in your dreams part, which I don't like that part. That's like too sing-songy. But the rest of it has like the whatever that kind of. Yeah, I like that.
Chorus that you don't like.
Yeah. I don't know. So is that weird? Sort of? A little bit weird? All right. What's up? Objectively. All right. So let's look at first one. So I gave you a list. So here's our list. 1, 2, list 3, 4, list 5, list 6. Close list, close list, close list, close list. Okay. And you're supposed to write the code that extracts. So let's just throw this inside of a define LOL to be this guy. Okay. So you were supposed to write the code that extracts the 6 from this. Now, my intention was for you to write a series of cars and cooters. Some of you wrote like a function that went through and checked for a 6, and that's fine. I guess you can interpret it that way. But I really wanted you to write a series of cars and cooters to, get this piece extracted from it. Now, one thing that was kind of often seen in this, where people went south, is this is actually a 3 list. This is element 1. This is element 2. This is element 3. All right, so the car of the cooter is this list. Make sense? So CADDR of LOL will give you that piece. Make sense? All right, now from that piece, what do we want next? We want the car of the cooter. Car of the cooter from that gets you that piece. The car of the cooter of that gets you that piece. And then you actually want the car of that to get you the 6. So that's the car of the cooter of that last piece, and the car of that gets you the 6. So there's our 6. Make sense? All right, questions on that one? All right. That one's missed a lot, which I think sort of surprised me. Maybe out of practice with cars and cooters, like that feels so weak too, or something like that. I don't know. All right, write a function named list_divisors that takes a number as a parameter, returns a list containing all the numbers that evenly divide that number. As an example, if the input was 9, your function should return 139, the elements that evenly divides it. And then I told you about a function called mod, So note that the function mod takes two parameters, returns the remainder of the integer division. So this is the way to find out if a certain value is evenly divisible by another value. All right, so define list O divisors. This guy's going to be a lambda that takes in a num, and it's supposed to produce a list that has all of the elements in it between 1 and num, including num, that evenly divide num. So we know 1 will evenly divide num, and we know that num will evenly divide num. So now we're looking for all the numbers in between. All right, so probably you're going to want a helper. So define list O divisors helper, let's say. And this guy would be a lambda that takes in a cur num and then maybe a num. So the current number we're checking against that guy, and then num. And probably also you want to take in your current list. That would, maybe this was the part where people kind of took a weird twist. That way you kind of have something to build on. All right. Actually, you could do it without the list. Let me do it without the list. So now what we're going to do is we're going to ask the question, if cur num is, if num divided by cur num gives you a remainder of 0, then we want to keep that value of cur num, right? And tack it on. We also want to stop once cur num is equal to num, once we've built up to that point. So we can throw some cons in here. So we can say equals num and cur num. So for instance, if the number was 9 that we're searching for, once we get up to that point, we're kind of done, right? So when we do that, we're just going to boil down to num. Kind of throw our 9 out there for that last value that we know evenly divides it once they match. Okay. Otherwise, we want to ask the question, if equals mod num cur num. So num divided by cur num, if that guy gives you a value of 0, that means it evenly divides it. Which means that we want to keep the current value of num. That needs to be tacked on to our answer, right? So what are we going to do? We're going to cons num onto the result. We might need to go back and look at this in a second. Cons num onto the result of, in fact we will. This needs to be the list of num because we're doing this as a cons. So cons num onto the result of list O divisors helper, passing it cur num, or plus cur num 1, and passing it num. All right, so if num is something we should keep, cons num onto the result of list of divisors, blah, blah, blah. Otherwise, boil down to list O divisors for the rest of it. And then this guy would just call list O divisors, passing it a 1 and passing it num, like that. All right, so our stopping point here in our pattern is if we finally hit the number we were checking against, go ahead and return the list representation of that number so we have that final value to cons onto. Otherwise, if the number I'm currently looking at is evenly divisible by the number that the number I'm currently looking at is evenly divisible by the current number, then cons that number, and this is actually wrong, cur num, cons cur num onto the result, so this is the number that did evenly divide it, onto the result of calling list of divisors helper on the next number and then the same num we're testing against. If it didn't evenly divide it, just go ahead and call list of divisors helper on the next number, so one higher and our current num. So she cons a bunch of stuff together. So list O divisors, what did I give it? The test case was 9. Oh, there is no mod function. Actually, there is a mod function. I think in reality, it's that. No, there isn't one. Maybe it's modulo. I told you that there was one, so given information was still legit. Is it modulo? Oh, list of divisors helper. Here's the 139. Okay, so here's the official scheme modulus function, but I told you there was one called mod, so that's the one you would have used in your response. Some people use the percent sign. I knew what you were saying. That's fine. All right, questions on this one? This one wasn't too bad. I think a lot of people got this one right or mostly right. So what I was really looking for is, do you understand how to check whether something is evenly divisible by something else? So this was one mistake people made a lot, not knowing that having a remainder of 0 means evenly divisible, which is embarrassing. Secondly, this might be falling out of practice type thing. Some people didn't want to do a cons. They wanted to construct lists. So then you would have had a result that was a list of lists. You missed like a point or something. You know, not the end of the world, because you would have had something that had the right values in it, just encrusted with stuff. But that was probably the other big thing folks missed there. Most people came up with the idea of using a helper and that kind of jazz. All right. 3, write a procedure called Fizzbuzz that takes a number as a parameter, returns Fizzbuzz if that number is evenly divisible by 3 and 5. Fizz, blah, blah, blah. Okay. So define Fizzbuzz to be a lambda that takes in a num, and we need to, we'll have our cond. Now, this one was important that you ask the right question first. All right, so some people miss some points because they asked the question where it's evenly divisible by both, like second or third, which means one of the other ones would have caught first. So in our cond, we'll say and equal. I'll go ahead and replace the modulo in here. Instead, you probably use the mod that I gave you on the exam. So if equal modulo num 3, so the number we're looking at divided by 3, if that guy is equal to 0 and equals modulo num 5, if both of those things are true, we should return Fizzbuzz. Otherwise, if it's evenly divisible by 3, it's just Fizz. If it's evenly divisible by 5, it's Buzz. Else, it's not evenly divisible by either, so it should just be the number, not false. So I don't remember if I took off for false. If I did, I took off 10 points. All right, questions on that one? Oh, here we can test it. Fizzbuzz. 9 should be Fizz, right? put my equals if that guy is equal to 0. Said it, just didn't write it. So there's my fizz. 3 and 5, what, 15? Should be Fizzbuzz. $10 would be Buzz. And 8 would be neither. Should just be 8. All right, so that's that one. Next. 4, write a lambda calculus expression where a variable x occurs free and a variable y occurs both free and bound. This was testing that you understand the lambda calculus expressions when something occurs and when something is bound. Remember we talked about that for at least a couple of classes? Still was missed way too much. So x has to occur free and y occurs both free and bound. So lots and lots and lots of different ways you could have written this. I'll just put it inside of a comment here. So you could have done something as easy as that for the x. So x occurs free, right? This would be our app expression for a lambda calculus expression. And then now y needs to occur both free and bound. So one thing you could have done is you could have said x, y. So just there you got your x and your y both occurring free in that particular case. And then for the other one, you could have said lambda y, y. So in that case, y occurs bound. So this is where it occurs. This is where it's bound. So this guy binds y here, but y doesn't occur until here. So this is an example where y occurs bound. This is an example where y occurs free. This is an example where x occurs free. And this is our lambda calculus expression, that is our app expression, that third one. This is our lambda calculus expression, that is our app expression, the whole thing, where the first element is an app expression, the second element is a lambda expression. And this lambda expression is where things get bound, right? And then our var expression is where things occur. Questions on that one? Okay, that one was missed too much as well. I think we had that as a homework assignment. We had that as a quiz. And we definitely talked about occurs free and occurs bound quite a bit. All right, so should have been 3 points. Let's see. Convert 1321 from base 8 to base 16. 1321. So that guy is currently in base 8, right? How can we write base 8 numbers in binary? Groupings of 3. All right, so we can take a 1 and turn that into a grouping of 3. So what's 1 in binary? 0, 0, 1. What's 3 in binary? 0, 1, 1. What's 2 in binary? 0, 1, 0. What's 1 in binary? 0, 0, 1. And then to go from binary to hex, we break it up into groups of 4. Right? This first guy, what number is this? 2. Second guy, this is the 1's place, the 2's place, the 4's place, the 8. So this is 13, which is a D. And what's this guy? 1. 2D1. Some people left this question blank. So now we pretty much knew a conversion question was going to be on the exam, right? It's not really an excuse for that. If you didn't know the little trick, so if you knew the trick, you recognize I actually gave you an easy question, right? I purposely gave you an easy question. But if you didn't know the trick, what could you have done? Well, you probably would have taken this guy and you would have converted it to decimal first, right? This is the 1's place. This is the 8's place. This is the 64's place. This is what, 256 place? All right, 64 times 8 is not 256. 64 times 8, 512. 5/12 place. So you would have first done the math of converting this guy to decimal. And then, once you had the decimal value, divide it by 16 over and over again to get the hexadecimal value of it. So even if you didn't know the trick, it wasn't going to be horrific to do, especially if you had a calculator. Make sense? All right. But this one was teed up pretty easily for you if you knew the trick. Questions on that one? All right. What's next? What is a grammar? What is a production? Oy. We've the whole semester we've been doing these. So a grammar is a description of a language, right? Formal description of language, something along those lines. Okay. What's a production? It's an individual rule within a grammar. Okay. So our grammars for lambda calculus expressions, for example, the grammar for a lambda calculus expression is a collection of productions. And each one of those productions, each rule that was in there represents some, the rule that makes something part of that grammar, fulfilling that grammar, part of that language, something along those lines. Make sense? Okay. In fact, in class, don't I try to use those terms specifically pretty often? So, yeah, that one was disappointing. That should have been, and I didn't even grade it very hard. I mean, there were some answers to that one were, a lot of people got the grammar side of it mostly right-ish, and then productions, they just made something up. Yeah, that one sucked. So then number 7, so this is after this given information. So I gave you a binary tree, so I'm going to write this binary tree thing out here. Bin tree. This guy is an int, or it's a list containing a symbol followed by a bin tree. Well, let's stay consistent with how I wrote my bin tree, followed by a bin tree. So those are the rules for that grammar. Now, this could also be written as that. This could also be written as that. Those are all equivalent ways of writing it. So this goes back to like week 1. But this is still the same version of the grammar that we've all kind of got stuck on, right? This is the one we like. Well, it's the one I thought we liked, but we didn't answer this one very well. So number 7, write an example of a binary tree that contains 5 numbers. So numbers are going to be these dudes. All right, so that means that we're going to have 5 elements of our binary tree that match this production. Okay, so to create a binary tree like that, we're going to need some symbols. So, and we need to have 5. So maybe we have a symbol A, and so now we're on this production. So we have a symbol A, so now our left tree is maybe our symbol B, and then its left and right tree, maybe we say 1, 2, like that. So this binary tree follows this production. This binary tree follows this production with the 2. Then we can have a C. Then we can have a D. Let's see, this is 1, 2. And I need a 3, 4 here. So 3, 4, those would be our next 2 numbers. And then we can have our 5 there. So that would complete an example of a binary tree with 5 numbers in it. So this outer one here is one that's a symbol followed by 2 binary trees. The first binary tree is that one, which is again the same thing, which is a symbol followed by 2 binary trees. Left tree is a 1, right tree is a 2. Here's the second half of that first one. It's the second production. Here's a symbol followed by 2 binary trees. The first binary tree is also our second production. Here's the symbol followed by 2 binary trees. Here's a tree by production 1. And then the second element of this binary tree, so the right subtree is just a binary tree following this production, which is a 5. Make sense? So That's an example of a binary tree that has, and I mean, you could replace this 1, 2, 3, 4, and 5 with your favorite 5 numbers. They didn't have to be 1, 2, 3, 4, and 5. I'm just old, and that was the easiest way for me to count up to 5 numbers. All right. So, in any case, should have been pretty simple grammar. Let's see, 8. Write a procedure called SomeTree that takes a binary tree as a parameter and returns the sum of all the numbers in the tree. Okie dokie. So I'll give myself a tree there. And so now we're going to define SomeTree to be a lambda. And this lambda is going to take in a tree as a parameter. Actually, let's call it a bin tree. A bin tree as a parameter. And what it's going to do is it's going to sum up all the elements in the tree. Now, when do we add stuff to our sum? When we run into a number, right? So, now, technically, we would never have an empty binary tree, correct? Some people tested for it, and that's okay. If you wanted to test for the empty list, not the end of the world, but this guy does not allow, we don't have a production that supports a binary tree that's empty. So we could just ask the question here, if number bin tree, boil down to that bin tree. Just kick it down a line here. Otherwise, if it's not a number, it must be the second production, right? So if it's that second production, what do I want to return? I want to return the sum of SomeTree on the left subtree, which is the CADR of bin tree, and SomeTree of the CADDR bin tree. So if it's just a number, return that number. Otherwise, it must be production 2, so return the sum of whatever SomeTree for the left subtree. This gives me the left tree of this guy. So the CADR gives me that dude. The CADDR gives me that dude. So call SomeTree on the left subtree, call SomeTree on the right subtree, add those two numbers together, and that's what we'll boil down to. So we'll call SomeTree on our tree here. This should be what, 3, 4, 5, 6, 10, 15? So there's our 15. Make sense? All right, questions on that one? What are we on? Number 9? Right, what is the purpose of storing lambda expressions in our variable environment? Okay, we mentioned this in class several different times. So the way functions are implemented in programming languages is by associating variable names with lambda expressions, right? A lambda expression is an unnamed function. Therefore, if we want to give a name to it, we would have the name of the variable associated with its value, which is a lambda expression. So why would we store it inside of our variable environments? So that our programming language can support function calls. Make sense? Otherwise, we have no way of calling this unnamed function. Okay, so that was 9. 10. Write a procedure called apply GD. So greatest divisor, I guess. It takes a list of positive numbers as a parameter and returns a new list of the same length with every number replaced by the largest integer value that evenly divides it. Okay. Now, I guess you could have done this a couple of different ways. Some people asked for clarification during the exam, but first thing that should have been going off in your head is map, right? This guy should have said, I need to map something, because we're doing something to every single element in my list. And what am I doing to each element? I'm figuring out what is the greatest value that evenly divides that element. Okay. Realistically, it's probably the greatest value that evenly divides the element that isn't the element itself, right? So, for instance, if the element was a 9, yes, 9 evenly divides 9, right? But the greatest value that evenly divides 9 is what? 3. So we would replace a 9 with a 3. So what we need is we need a define, maybe called GD, greatest divisor, something like that, that is going to take in, it's going to be a lambda, that's going to take in a num, and it's going to figure out what the greatest value that evenly divides that number is, right? Okay, so now we have one limitation with map. One limitation with map is that map can only take in a single value. All right, so if we're going to write this guy, we really need a helper function to pass this guy to, right? So we're going to need a GD helper. And you could have done this with like lets or something like that if you really needed to, but we're going to do a GD helper here. This guy's going to be a lambda. It's going to be similar to what we wrote earlier here. And this lambda is going to take in maybe a kernum and a num. And we probably would want to count backwards, so it would be faster to start at the number itself, -1, and then count towards 1. Okay. You can throw some error checking in to make sure the number wasn't 1 to begin with or something like that, but for the sake of an exam, as long as your logic was mostly right, we'll say that was good. So what are we doing inside of this guy? We're asking the question, if equals modulo num kernum is equal to 0, that means I have found a number that evenly divides kernum, and I'll go ahead and, or I have found got these backwards here. No, I had it right. So I have found a kernum that evenly divides num, and that should be the largest one, so I'll go ahead and return kernum. Otherwise, I'll call GD helper, passing it kernum minus kernum 1, and passing it num. And we would assume this guy's going to eventually finish once it hits 1. Okay, you can throw error checking in there and stuff if you want to make sure that it's doesn't break. Technically, we would have to be careful about negative numbers here as well. So, you know, if you wanted to write some additional logic to handle negative numbers, but you can just assume everything's positive if you wanted to. So, GD helper, this guy's going to take in what presumably will start off as the number that's 1 less than num and num. Check to see if that current number evenly divides it. If it does, return that number. That's the largest number that evenly divides it. If it doesn't, go ahead and call GD helper again, passing it one number that's smaller, and test that one. Okay, so then inside of GD, what are we going to return? We're going to return the result of GD helper, passing it minus num1 for our kernum, and passing it num. And then if we go ahead and give ourselves a test case, so define test to be, what do we want to do, like 3, 4, 5, 6, 7, 8, 9, something like that. We would then, what did I tell you what to call it? Apply GD. Define apply GD to be a lambda that takes in a list and should replace each element of that list with the greatest common divisor of the element of that list. So we'll map a function, what function? The GD function, onto my list. And then we'll test that by calling apply GD on test. So a 3, what's the greatest number that divides 3? Should be a 1, a 2, a 1, a 3, a 1, a 4, and a 3. So that's the result there. All right, questions on that one? All right. So that was the exam. So after the fact, not maybe as bad as it felt initially. What do we think are the were the issues with the exam? Was there was it a time crunch? Okay. Okay. Now after going through it, should it have been a time crunch? Or I realize I maybe go through it quicker than you might. So even after seeing the answers, is if you had prepared differently, would it have still been a time crunch?
A little bit less. I think the only thing that ever really makes it a time crunch with these exams is obviously you can't compile it. So.
Well, right, and that's true. And when I grade, I take that into consideration. I mean, some of when you look at what you wrote and you look at whether you missed points or not, you'll see that you typically get points if what you wrote is, makes logical sense, but it was pretty clear that, oh, well, heck. Like, for instance, like I made that mistake up above where I didn't say whether it was equal to 0, for one of the modulos. I did it on the left hand, but not on the right hand. If you've shown me that you understand you're testing to see if it's evenly divisible by something and you did it in one place but forgot to do it in another, I'm not taking points off for that. If you never showed me that you knew how to test to see if something was evenly divisible, well, then I don't have that evidence. But that would be an example where something you didn't have time for it. Okay, yeah, because typically what I'll do is when I go through an exam, so what we just did in the time period is we started off class, we talked about some stuff, right? So we didn't even start into this for a little bit. And then I went through and I explained the entire exam as I was solving it. So it feels like that should, but it was a push. It was close to a time crunch, but should have been doable, but maybe could have been a question shorter. Something on that ballpark. All right, so keep in mind that the final exam, which, like I said, you can replace this exam with what you get on the final. The final exam will be very similar to this one in length, but you'll have twice as long to do it, right? You have the full 2 hours. So expect kind of the same footprint exam. I won't make the exam twice as long. It'll be the same footprint exam. So if you feel like your deficit here was time-based, you'll have twice as much time for the same material for the final. Sound good?
Yep.
All right. So we'll call it quits. If you have any questions about how I graded a particular question, let me know. If you think I gave you too many points for a question, let me know that as well. I'll take some back. And I'll see everybody on Wednesday. Expect some new homework on Wednesday. I'll also put up the Bible homework later today.